Hi everybody, my name is Rick Butts, creator of Edestol. In this video, I'll be showing you how to use the motor import feature of the program. I know we generally collect motor lists as preliminary engineering documents. Well, I've created a way for you to quickly and easily import those right into the program, right into your power module, and eliminate the need to drag and drop every motor into the program. So let's go take a look. Okay, here we are. Let's create a project to import our motors. All right, so we're going to just say File, New, and we'll put it in the current, just the default Edestol project subdirectory, and let's call this Import Demo. Okay, and we're going to just start with an existing. There we go. Let's call it MSG existing 480 volt. All right. It's not going to be service entrance. It's already wired up. Everything's set to go. So this is just our voltage source. We're going to use 480 volts. The switchgear has 3-4 available. We're going to be doing some importing of motors right here. So you can only import motors into one component, and that is, and you can only do it for voltages lower than 1,000 volts. So typically it's reserved for 480 volt motors, and you import them into a motor control center. Motor control panels you cannot import motors into because they are on the ends of power distribution blocks and taps and individual breakers, fuses, things like that, protective devices. The motor control center has just a common bus, and I have allowed the capability of inserting motors on MCCs. You do not have to have, you don't have to have the motor starting device, the ASD, the full voltage, or the reduced voltage starter before you import it into an MCC. So in order to get an MCC, you can't go just from an MSG as main switchgear. You got to go with a protective device. So let's just add a circuit breaker. And let's say that there's, I don't know, maybe 7 circuit breakers already in the switchgear. So this is going to be, and we're going to say this is feeding MCC1. And let's just make it 800 amps. We don't really know how big it's going to be. Well, as we add motors, it'll tell us what it needs. There you go. 3 phase. The circuit breaker itself has ABCN, so it has neutral capability if you wanted, but it is just simply a 3-pole breaker fixed. We could go adjustable if we wanted, do 800, reduce it by some percentage as your typical circuit breakers, but let's just go with a fixed breaker. Okay, so we got a fixed breaker there, and then we're going to just copy this one because we actually need 2. We're going to do 2 motor control centers. And it's going to be a new branch, and we'll call this 9, and then this is for MCC 2. And in this case, let's just go with a 400. All right, there you go. So now we've added 2 circuit breakers into our existing switchgear. Got no connected amp, no minimum circuit sizes, the whole bit. So now we're going to go ahead and we're going to create our motor control center. So let's get a motor control center, say MCC1, and this is going to be a process MCC. And since it's tied to a circuit breaker already, it chooses the bus size that you can go larger, but you can't go smaller than the protective device that's upstream. And also you have the option for main lugs. You could do a circuit breaker, fuse disconnect switch, molded case switch, whatever, but we're going to go with main lugs. It's all going to be in the same electrical room, and we need a cable. We're going to go ahead. So basically our circuit design size for the cable feeding this device is going to be set to 800 amps. So let's go ahead and we could go in and do our attributes. You guys have seen this before. You know, incoming bus, what your bus bracing is, bus material. You could pick all sorts of stuff you wanted. So let's do that. And we'll have to create our, let's do Houston wire and cable. We're going to stay with single conductor 90C copper stranded raceway, no cable tray in this situation. And like I say, single conductor. And since it's in the electrical room, let's just do EMT. So it's sized and the ground specs are same as the phase. So we'll just do a, you can see you've got the same style, you just a different size for your cable, actual part numbers there. Looks like you need 2 3-inches. So there's MCC1, and let's go ahead and just copy that down to, and these are all right clicks, paste device, and we'll do this as a MCC2, but in this case, let's go down to 400 amp main lugs, same deal. Okay, so now we will create a feeder cable. It's all the same thing, EMT, because it's going from the switch gear and to the MCCs in the same room, and it comes up with 3 600s and a number 3 with 1 parallel run. Okay, so there's your feeders. And you can go down here and you can look at your different cables. So you've now created 2 parallel feeders going from CB8 to MCC1, that's these down here, and then 1 feeder going from CB9 to MCC2, all right? So now what we want to do is we have MCC1 and MCC2, and we want to import motors, okay? And we're going to go up here and we're going to do this little import thing. But before that, what I want to do is I want to show you how you do that. You import from a spreadsheet, and we're going to go to our Edestol subdirectory, which has, here's where our project is. As you know, you've seen this in other videos. There's our project, and we have this import export. So basically, we have given you 2 of these spreadsheets to work with. One is for motors and one is for controls, and it gives you the setup for the spreadsheet that's required for the program to recognize it to import motors. The next video I'm going to do here real shortly is going to be on importing controls, but right now we're doing motors. So let's just go into motors, and you can see that we've just got basically semicolons or comments, then you got your headers right here, and then you have a list of your ID tags, and then what their descriptions are, size, and then size units. And you can read the kind of the rules here. Motors may only be imported to 3.3 or 3.4 MCCs where VLL is less than 1,000. Comments are located left column to begin with a semicolon. Gives you lists on ID tags that work and everything like that. Now here's the other thing is that down here, this tab has to match the ID tag of the motor that you want to insert it to. So let's just change this. This is going to be MCC1. And then what we're going to do here is we're going to say mover copy. Let's just create a copy. Okay, and this one is going to be MCC2. If they do not match, you will just get an error on imports that says couldn't find the MCC that you're looking for. So this is now, now that's M3, so let's just go M4. Okay, 4, 5, 6, and then we're going to replace process with, let's just call it loadout. Control H, process, space, loadout, space, and we're going to replace them all. Okay. And rather than 150, let's do 150 and 25. Okay, so there's our horsepowers. You could do kilowatts or horsepowers over here. So now you basically have your MCC1 and your MCC2 in your spreadsheet. Now I would go ahead and recommend that you then save this as a, where are we? Save a copy. Same place, Edestol import exports, but we're going to call this MCC1 MCC2. All right, just to separate it from the document that you get with the program. Then you'd have a standard base system. You don't get that mixed up. If we have to come in and one day overwrite the import template, if you will, this spreadsheet template, if we need to overwrite that, you don't want to be overwriting existing motor lists, things like that. So there you go. Now you got your MCC set up, or your import spreadsheet. So we're going to go back over to our program. We're going to do utility import motors, and it goes right to your import export subdirectory. And so let's do that. And it finds MCC1. And so you see here what you've got is M1, which is, and it's going to be fed from MCC1. That's the tab. And here's your process line 1 extruder main drive, 250 horse. And there's your circuit design size. Your connected amps, which is 302. Circuit design size for a motor obviously is 125% of this. If you wanted to do things for a motor, you could maybe they're all TESC, synchronous speed 1800. You could do this. There's no classification, and away you go. So, and we're going to create a cable as we do this. And this is the cable. Obviously, we've talked about this in previous videos, that actually connects to the motor. So in this case, that's probably going to be a liquid-tight, flexible metallic conduit. It's going to be in the field. So let's give it 104 ambient temperature. It'll compensate. So you've got one set of 500s to number 3s, but you know what? One set of 500s terminating to a motor itself is kind of difficult, so let's just give it 2 parallel runs. So now it's 2 sets of 3/0s, and we're going to stay with single conductors, because this in the long run will just be the connection between the disconnect switch and the motor itself, and it's going to be going through liquid tight flexible metallic conduit. So it'll be 2 sets of 2-inch, and the ground is the same spec as the phase conductors. All right, so there you go. And it comes up with M2, process line extruder former, 200 horse, same routine, except in this case we've got a little bit smaller final design. So it'll create a cable for that. There you go. It's 350. Same setup from the last time you created a P cable. It's 104. It's LFMC. Ground specs, here we go. And then you got M3, okay? Same deal. It'll just come up with a new. So it gives you a really quick way, rather than dragging and having to configure every motor, especially typing all that stuff out from a description standpoint. It's all easily just imported. Same deal. We got 3 sets of 4/0s in, and a number 4 ground. So there you go. Now, you'll notice it had finished those 3 motors. So now we're to motor 4, and it found an MCC2. If it didn't find an MCC2, it would abort all those motors on that spreadsheet. And you'll get a message that says, hey, couldn't find MCC2, and you'll notice obviously that you don't import them. So in this case, we got 100 horse, same wiring specs. And everything's the same here. If you wanted to change some stuff, you could, and then that would be the next memorized or remembered settings. So there's your M5, away you go. And this is the M5 cable. This is the M5 cable. And then M6 from MCC2, load out oven, drive belt. Everything's okay. And so what you have done now is you have created all your cables for your motors, and you've got your motors in, and you can really quickly look, well, what was the load on this MCC? So basically you've done these real quick calculations, and you can see the connected amps are 180, 240 plus 302, and they all add up to 722. The actual circuit minimum size is the sum of these motors plus 25% of the largest motor, and you can look at that in a different way over here on circuit calculations. Okay, where, okay, we don't have any connected, we don't have any continuous amps or non-continuous amps. We don't have single phase loads. We have all motors. So basically you have connected amps plus 25% of your largest motor gets you your minimum size, which is 797.5. So, and we have 800, so that's technically you're good there. It won't take much though to put us over the limit on that. But there you go, there's your importer on the motors. Let's go ahead and just, let's do motor control. Let's just add a adjustable speed drive. We want an adjustable speed drive on M1. So now you got ASD M1. It remembered the process line extruder main drives. It's gonna be a circuit breaker main device. It picks, this is an extruder, so let's go heavy duty. So it picks the heavy duty, the 250, but heavy duty is a larger drive than normal duty, so you get that. Now in this case, as I believe you've seen on other videos, the input rating on the final circuit size speeding in ASD is 125% of the input rating. So you got input rating here of 283.5. Your final circuit design size is 354.4. Your connected amp is still your motor. The drive does not contribute to connected amps. So your connected amp is still the 302, which is the number out of the table. So there's your drive there. And you could go ahead, as we've seen in other videos, you could add starters or reduce voltage starters. Let's do a disconnect here. Switch devices, disconnect switch, put that on the motor. It'll tell you it needs a 400 amp switch. In this case, what we're gonna do is, we'll go do a cable. All right, so now you have a disconnect. In this case though, we wanna go multi. Okay, and in that case, it's gonna be a 3-conductor HWC, and it happens to be a tray cable with exposed routing red on it. So still it's 500s. Those are pretty hard to make up with a motor. So let's make 2, and it cuts it down to 3/0, 104 degrees. And in this case, where we use raceways, it's not going to be a liquid tight flexible metallic. It's going to be rigid metallic conduit. So we're going to change to that. Now you'll see over here on your fill limit that you got 51%, because you only have one cable in that conduit. And excuse me, not 51, 53. But we're looking at, in the fill's like 46.5. That still seems a little bit excessive. So let's just bump that back up to 40. And that moves us to a 2.5-inch conduit. So there's our fill now. You got one cable running through that conduit. All right, there is no ground. It's with ground, there is no neutral. And away you go. Okay, and now you see you've got your cables here running to from your MCC to your motors, to your M1A, M1B. This is from the disconnects to the motors. This is from the MCCs, or actually from the ASD to the disconnect itself. And you have all these cables here. We've created them. In future videos, we're going to drag all these down here to conduits, and we're going to create our conduits. So we'll do that real shortly. But that kind of gives you a real quick and dirty look at how you import motors using the spreadsheet. The next video, we're going to do import controls. So have a nice day. Take care. Bye.